Hello class, in today's lesson we are going to discuss about the steps to follow when designing a database. By the end of this lesson, everyone will be able to follow the steps, then design a logical database schema, and everyone will be able to elaborate all steps followed to design a good database. So before designing a database, or before purchasing a database, you have to think before why you need a database. After finding that you really need a database, next you need to identify the outcome from the database by establishing the requirement specification. Then after finding that the requirement specification are really good, then you have to sit, then you plan for the database, you plan for it, and you plan for it. And when you find that the data is more complex, there you need to more plan. Even the simplest database should be thought of on paper before it starts being created using your computer. So which means every time before going on computer, start writing your program, you first need to plan for it. A well-designed database will perform well and it will adapt to the future needs by giving users access to essential information. But when it's poor planned, the result will not be good and it will obviously fail to meet the overlooked needs. So when you are planning, when you find that you need to develop a good database, you need to sit, then you follow the steps. The steps you are going to follow: number one, you have to investigate the information. What are the information you need to include in your database? Then you gather information from different areas of the institution where the database will be used. After getting the information of what you need to include in your database, you have to sort out that information you've gathered. Then you try to categorize by identifying the object. This is the object student. This is object subject. This is object school fees. This is object academics. Then you try to identify such objects. After identifying the object, now you are going to model those objects. Then after modeling the objects, you need to identify the types of information for each object. Then identify the relationship between the object. What is the relationship between the student and the school fees? The student pays school fees. What is the relationship between student and subject? The student study a subject. So you identify the relationships between those objects. After, then you need to optimize. You need to find that there are no anomalies or non-consistent data which may appear. So in that case, you go through what you call normalization. Normalization is a step-by-step of finding anomalies or faults in your database, then try to remove them. After you find that your database is normal, is well organized, then you test it with real and correct data. Then you try to manipulate the data and see if it is giving the real output. Then if you find that it is working well, then your database is good. Let's go through the steps. Investigate the information, which is step number one. Before creating a database, there is a need of good understanding of the problem that the database is expected to solve. So first you need to understand what is the problem that requires that requires the database use. So if the database is to replace the traditional method, file-based approach, then existing system will give most information you need. So in organization, there was a way they have been using to manage the information. So that way can give you a clear picture on how you can start your database. Then you base on the actual data, then you computerize that information. Then during the investing the information, there is a need to work with everyone involved in the existing system. So if it is a school database, you will go on the ground, then talk to everyone who will be using the database. For example, the academics. You talk to teachers, you talk to dean of academics. You need to manage finance. You will talk to person in charge of finance. So everyone who will use the database or the system will be involved in gathering the information. Step number 2, after gather the information, so you need to identify the important entities or the objects as well as their attributes. So during the process of gathering information, the key objects or entities that will be managed by the database must be identified. Here the object can be a tangible thing, such as a person. For example, in a school there is students, in a given institution employees, the patient in hospitals, management, and so on. So those are what we call objects. What can be a more intangible item, such as department in an institution, a combination in a school, attendance, and so on. Each distinct item in the database should have a corresponding table for which column titles are attributes and the entities. For example, if it is an entity student, so what characteristics of the student? The student can be characterized by a number, the first name, the last name, and so on. So you identify all those information. So we call this attributes, call them attributes, while this is an object, or simply we call it a table. So after gathering information, you are going to sit, then identify objects as well as their attributes. Step number 3, you are going now to identify the relationship between entities. So now in the school, here we have students. Then we have combination as another object. So what will be the relationship between a student and the combination? So the student will study in a combination, or will be registered in a combination. So this is a relation. This is a relationship, and for every step, for this step number 3, you have to identify the relationship between the object. Remember that here we are in a relational model where the entities in the database should be related to each other. Step number 3, now you are going to model the object. As the object in the system and the attribute are identified, they are recorded in a way that represent the system visually. So now here in modeling the object, we use a technique we call an entity relationship model. In the relationship, in entity relationship model, we have what we call ELD, or what we call entity relationship diagram. So the entity relationship diagram are going to be designed so that they give a clear picture of will look, how will look your database. For example, you have a student here, then you have a combination, then here we will see in the next slides, we'll see how the symbols we use for modeling the object. The object is always in a rectangle. Then you are going to establish a relationship between the student and the combination. So what will be the relationship? The relationship will be, for example, study in a combination. So this is the relationship. But this student also should have a list of attributes like first name, age, last name, and so on. Also, the combination will have its attributes. And here we'll identify what you call the level of participation. For example, for how many combinations a single student can study in. So we find that a student is studying in and one and only one combination, because you can't study in MPC and MPG at the same time. But in each combination, there may be one or many students. So we call this level of participation, or we simply call cardinalities. So here you are trying to model the object in such a way that gives a clear picture of how the database will look like. So we'll discuss more about this when discussing about relational database model design in the next unit. Number 5, after identifying the modeling your objects, now you are going to identify types of information for each object. So here in this, for example, the student, you are going to identify what will be a unique identifier for each student, because we have many students. You may have 5 students with the same first name, last name. They may come from the same village. So how will you differentiate these students? So in that case, you need to identify the types of information which will be stored in each the object by specifying what you call columns or fields. These are attributes, as we saw. For example, in a database of the name and address, you would keep each part of a person name and in a separate field, then address in another separate field. So here we need to identify the raw data column. So these are columns, these columns store a tangible piece of information such as name, address, age. So we call this raw data column. In other types of information, you need to identify categorical columns such as marital status, gender, for example, qualification. Maybe someone is bachelor, master's, so we call them categorical columns. So there you will identify what are the raw data or the raw columns, then categorical columns. Then you need to identify the what we call identifiers. Which column, which data may differentiate one student to another. So for example, in a school, the registration number is a unique item that will identify each student. After identifying the identifier column, then you will identify again the differential column. For example, in a student, we have a student, then we have combination. How will we know which student is registered in which combination? So we'll have to identify what we call differential column, or we simply call this the foreign key. So we'll understand well this in the next unit. For example, an entity that tracks sales transaction will generally have a link to the customer's entity. So which means it's the customer who have made a given transaction. Step number 6, now we're going to go through optimization by normalizing your database. This is the most step you have to consider, because it's this step which will give you, or which will show you that your database is perfect or it's not perfect. By doing what? By trying to enforce redundancy elimination, and inconsistency dependency should be removed. So we'll discuss the normalization in later unit. But this is a step that will try to investigate, to diagnose if your database is correct. Then step number 7 is now to enter data. Then you try to manipulate the data and see if it is giving out the intended output. So if you enter the data, for example, you enter students, you register combinations, you register subject, you try to see if you can get students from each combination. Then you can see if you can get the list of subject per combination. In that case, if you are getting a good result, means that your database is well designed, and that will be the last step to ensure that your database is well designed. So thank you for the lesson. So go through the assignment and try to follow the steps so that you can identify what to be done at each step of this assignment. Thank you.